Hey everyone, welcome to X Transform. Today we are breaking down a big fancy term that you have probably heard before, machine learning. Don't worry, it is not as complicated as it sounds. By the end of this video, you will know what exactly it is, how it works, and why it is so cool. Ready? Let's dive in. Studying machine learning as a beginner could be very frustrating, and if you are presently having difficulties understanding what a model is, it is absolutely normal, and this video is here to help you develop the needed foundational understanding. In machine learning lingo, a machine refers to a computer or some computational systems that are designed to learn from data, identify patterns, and make predictions or decisions on them. What does learning mean? Machine learning is like teaching a computer to learn, that is, acquire knowledge and patterns from experience. This experience is the data that is fed into it, just like humans do. The difference, however, is instead of giving the computer a list of exact instructions, we give it data. In addition to this data, there is a multi-purpose instruction, an algorithm we have provided the machine which determines how it should process the supply data so that it can figure out the patterns in the data on its own. Cool, right? For example, we could show a computer lots of pictures of cats and dogs and it will learn to recognize which is which. During training, we tell it explicitly, hey, this is a cat or this is a dog. It begins to form and discover the patterns in the data that you have fed it. Let us go into the art of it. What is a machine learning model? Think of a machine learning model like the equation that the machine has figured out from the data that it has ingested, expressed in some mathematical form. This is as basic as it can get. Let us go step by step. First, you have to start with data. Think of data as the specific information you want the computer to learn from. For example, pictures of cats and dogs, or even numbers like the house prices and their sizes. Train the model. This is like teaching the computer using data. The computer looks at the data you have provided it over and over again and learns the underlying patterns. Look at the data and try to figure out what is happening. Have a more careful look into the table and see if you can discover the relationship between the price of the house, price per month, and the number of rooms in the house, and if this price per month is also related to the location, being either it is located in the city center or not. What do you think a 4-bedroom house in the city center will cost? After a few tinkering with this data, you may figure out that the underlying pattern is, if the house is in the city center, the house price will be number of rooms multiplied by £1,000 plus £1,000. And if it is not in the city center, the house price is simply number of rooms multiplied by £1,000. Together, look at it this way. When you go through this data, it is like telling the brain when the number of room is 3 and it is in the city center, then the price is £4,000. Again, when the room is 2 and it is not in the city center, the price is £2,000, and so on. Brain is in the process of figuring out what the relationship or equation could be, such as y equals the number of rooms plus city center value times £1,000. We say we are in the process of training. At this stage, we are trying to figure out if the equation is correct or if £1,000 here should be 500 or if the plus sign should be negative. When everything is set and the equation seems to be correct or very close for every instance in the table of values, e.g. when you slot in number of rooms as 9 and yes to city center, you got £9,000. Then you think the equation should be right. Then we can conclude that training is completed. We have figured out the relationship between the price of the house depending on the number of rooms and its location. Hooray! Your brain, a natural machine in this context, has learned the underlying pattern for this simple data. If you believe this data is representative of what obtains in all situations, then you can answer the previous question comfortably, even if you don't have any 4-bedroom house in your data. Note, the figure you would get for the 4-bedroom house is going to be an estimate, simply because all models are estimators. But our brain has successfully done this because the table of values dataset is small. If the table of values runs into millions, which is the case in our real world, we may need days or months to do this. This is the reason we usually need computers that have more speed and computational capabilities than the human brain to help us out. But before the computer can proceed with this, we need to tell it the general purpose way to achieve it. This is where creating and coding an algorithm into the computer comes in. The machine, computer, can achieve nothing without these algorithmic inputs. But how exactly do computers recognize the patterns inherent in this data that we have? It starts with humans. Humans must tell it how to process the data in the table and discover the underlying pattern. But how? We must first figure out the process that leads to the solution, and more importantly, document how we came about the equation. To repeat, when we have figured this out, we must write out the process of arriving at the equation in a step-by-step manner to arrive at the corresponding pattern or equation. This step-by-step approach to arriving at the equation of the line is what we refer to as an algorithm. We would have to transfer this algorithm to our computer using a language it understands. This is computational thinking, so that it can replicate a problem-solving approach. The logical and obvious next question will be, but how do we do these as humans? How do we determine the equation that satisfies the data in the table? We'll come back to this in a minute. Our intention of developing a machine learning model is to write the step-by-step approach into a computer system or a program, by the end of which the machine will be able to figure out the relationship as y equals to the number of rooms plus city center value times £1,000. That sounds like a lot already, right? But there's something more important. We must ensure that we have a sizable volume of data so that we are certain that the patterns we have drawn or figured out is valid and general for all inputs. A lot said already. Remember, solve it, write it down, instruct the computer to follow your steps, pass this solution to the computer using computational thinking. The next thing we have to do is to test our model. But how do you test your model? After learning, you give it a new data to see if it can make accurate predictions. This is like saying, did you really learn this, or are you guessing? Did you actually get the underlying pattern, or making random guesses? How do we then achieve this? Simple. If we have 10 entries in the table like we can take out 3 of them. These 3 are chosen randomly. We would only use the remaining 7 to figure out the patterns. When we have figured things out, we will then check the validity of the relationship, I mean the equation that we've come about, using each of the 3 entries that we held out. The entries that we have held out, 3 in this situation, is what we refer to as the test data. The remaining 7 that we use for the training are called training data. The equation we arrive at has been the equation of the underlying pattern, which is now true for all the instances in the table, is called the model. That the model is true for all the data and that it predicts well and correctly on a 4-bedroom house that was not even in the data that we use to train the model is referred to as generalization. We say in our lingo, it generalizes well to unseen data. In the end, the model becomes a tool for making predictions. It might say, based on what I have learned in the data presented to me, for a 12-bedroom house in the city center, the price will be £13,000. And that is it. Okay. So now you know a machine learning model is like a learning tool for making predictions. Like driving cars. These cars use models to identify roads, stop signs, and pedestrians. What they have seen before has been used to create an equation which, when the next picture or sign is supplied to them as an input, they give the right output as a prediction. Pretty amazing, right? Machine learning models are so powerful because they can handle huge amounts of data and they learn super fast. And because of the speed, They can make decisions in ways that are faster and much better than humans can do. So there you have it. If you haven't learned anything today from this video till now, I would like to leave you with the following. A machine is a computer, a device, an equipment, or any other item that is computerized and can do something that humans will normally do using their natural intelligence. A model is simply a mathematical representation or equation of an entity, phenomenon, or an activity. Training, that we also call learning, is the process of giving the machine several data inputs so that it can use that to figure out the underlying formula or equation with the intention to use that equation later to provide an answer to subsequent inputs. This is also what we refer to as prediction. In the next video, I'm going to take you through the step-by-step process of developing the algorithm that instructs the computer how to figure out the pattern, the equation that shows the relationship between the variables, input and output of the table that we used in this video. The computer will figure it out itself. If you give it other similar tables, it will use the same algorithm and figure out what the equation should be. This is how learning is done. When this is scaled, you then have computers being able to recognize pictures, recognize pedestrians crossing a road, identify the speed limit for a given road, and so on and so forth. If that sounds good to you, watch out for the next video. That said, if you enjoy this explanation and want to learn more about machine learning, AI, or tech in general, don't forget to hit the like button, subscribe to my channel, and share this video with your friends who may find it useful as well. And hey, what is the area of machine learning that you would like to have more clarity on? Let me know in the comment section. See you next time. Thank you.